Moving now to the Heron plugin and topography. To coordinate the two datasets, use the set earth anchor point component from Heron and connect the file path param from the OSM file above into the read file component here in section 7. This will read the longitude and latitude coordinates from that file so that they can be used to situate the anchor point for Heron, that is, to tell it what coordinates the origin point represents. If you have a licensed version of Rhino that is able to connect to the internet, Heron is able to download various open source topographic data and read it directly through a REST API call. You need to provide a file folder, which can be done by referencing a directory in a file path param or by pasting the path into a panel, as done here. You also need to give the file a name in the prefix input, change the data source from SRTM to Copernicus for more recent data. A 30-meter grid is the highest resolution you will find outside of the United States or some paid sources. For the boundary input, you can either input a rectangle of your own or use the boundary output of the Caribou component above for a precise correlation. Finally, set the toggle to true. This process creates a triangulated mesh, which can then be analyzed or processed by any normal geometric means, like slope, aspect. If the mesh does not seem to appear properly, check your display settings, wireframe versus shaded, and whether display mesh edges is on or not. Here there is a contour component with a 10-meter interval. Meshes can have image textures applied to them, and Heron is also able to fetch a handful of these. Some are only available for the US. It is recommended that you use a specific folder for each project because this component will overwrite the file each time it is called. Again, using tools from Human, these image files can be mapped onto the mesh and both previewed in Grasshopper or baked to Rhino with them applied. Render settings sometimes cause these to appear all black, however. If so, from scene lighting to ambient occlusion should fix it. Finally, the two datasets can be brought together using Move to Topo component. As the tooltip describes, this moves geometry in the Z direction until they meet the mesh. Meshes and B-reps are placed at the intersection point of their lowest corner, so they appear grounded and not floating. Curves are moved so that each of their vertices sits on the mesh.